So, combinatorics. I think that all of you know about combinatorics, and let's just revise materials. So, permutations. Permutations. If we have an element, for example, A, B, C, D, F. So permutations, it is n elements from n elements, but in different kinds of position of the elements. For example, the first permutation, it is sequence A, B, C, D, F. The second permutation, it is sequence of B, A, C, D, F. So I change the elements, change the positions of elements, and I make another permutation. And number of permutations. So the first we can draw boxes, n boxes, and the first box can be filled 1, 2, 3, 4, 5. One of 5 elements. Then the second box can be filled n minus 1 elements. Yes, because one of elements already here. So 5 multiplied by 4. The second box just n minus 2 elements. It is 3 and so on. 2 multiplied by 1. And it is so number of all permutations of n elements, it is n factorial. N multiplied by n minus 1 and so on, multiplied by 1. The next, it is about permutations. The next configuration, it is k permutations of n elements. So k permutations, it is, for example, A, k permutations of n elements. It is sequence of k elements which we take from n elements. It is, for example, if k will be 3, it is A, B, C, or A, B, D, or C, D, F. And the order is important. So C, D, F and D, C, F. It is 2 different k permutations of n elements. And we can count number of k permutations of n elements as well as just permutations. It will be these lines, it is like number of elements of this set. So number of k permutations from n elements, it is also n multiplied by n minus 1 multiplied by n minus 2, as well as here, and so on. And the last element will be what?
1.
No, not 1.
N minus k.
N minus k. Are you sure? N minus k. Let's check. If n equals to 4, and k will be 3. Yeah. So this box, how many variables? If n equals to 4, k equals to 3. How many variables can be filled here? We have 4 elements, so 4 different variables. 4, then multiplied by 3, then 2, and 1. It is 4 permutations. Okay, if k 3, so it will be let's if k will be 2 boxes, so it will be what?
2, 1.
Here must be one of these 4 elements, yes, 4 variables, multiplied by 3. Is it n multiplied by n minus k? N minus k. N, it is 4.
It's 2.
N minus k, it is 2. So here it will be 4 multiplied by 3 multiplied by 2. It's not correct. Because the last element less than k, so not less, k less, bigger than k, 1, yes, 1. So I need not minus 2, but minus 2 plus 1, yes?
Yes.
K minus plus 1. Is it correct now?
No. Why do we have that? Why do we have k plus 1 inside brackets? It's going to become n minus k minus 1.
Just now. 4 minus 1, minus 1, sorry. Not a plus 1, minus 1. Yeah. K minus 1. Less than k, more than 1. Yeah. Thank you. Okay. And how I can get the formula of k permutations? of n elements. Is it possible to multiply by something and divide it by something? Or what? Multiple by n minus k. Yeah. Multiple by n minus k plus 1. And so on. Multiple by 1. Yeah. And the same expression here divided. And it is what?
N minus k victory.
Minus k. Minus k factorial. So it will be n factorial divided by n minus k factorial. And the last combination, it is combinations. Combinations, it is like k permutation of an element, but the order doesn't matter. So here from C of k elements from n elements, it is like k permutations, k permutation of an element, but order doesn't matter. So it is not sequence, it is set of, let's k will be 3 and then will be 5. So it will be A, B, C, and B, A, C. It is absolutely the same combination. A, C, Z, yeah. A, Z, F, and so on. And it is obviously C numbers, number of combinations less than number of k permutation of n. So if k will 3 here and 3 here, n will be 5 here and 5 here. So numbers of combinations will be less. Yeah? Is it clear? And in how many times? How many times? Number of permutations of these elements. Yeah? Because here order doesn't matter, so this and this the same. And C, A, D the same. Yeah? So how many same combinations will be here? How many? How you can count it? A, B, C, B, A, C, C, A, B, C, B, A. How many? How you can count? Formula. I asked formula. But not n, but k factorial. Yes, k factorial. So number of combinations of k element from n element will be less than number of k permutations of n in number of k of permutations of k elements. Yes, and it is n factorial divided by n minus k factorial, k factorial. Okay. So I hope that you remember about hypercube. You can count number of vertices in each level. Yes, how many vertices will be here? How you can count it? Level number 3.
Six.
2 digits 1 and 2 digits 0. What formula will be used for me to count number of vertices?
I think 2 raised to power.
No.
Power. I would like to count 1, 2, 3, 4, 5. How many?
We use combination.
Combinations. How?
We use 2010 is equals to 4.
And it is 4.
Because we have 4 digits.
4 positions. Yes. 4 digits.
And we are trying to arrange 2 digits.
2 digits.
Yes.
1 or 0.
Yes, we're trying to arrange 1.
For example, 2 digits 1. Okay.
So we have 4 factorial over 4 minus 3 factorial, 2 factorial.
And why k will be 2?
Because we are trying to arrange 2 digits of
And why it is combinations but not k permutations of n?
because the order doesn't matter.
Order doesn't matter, yeah. So 0, 0, 1, 1, or change this 1, 1, 0, 0, 1, 1, the same, yeah? Okay, so for example, it is position A, position B, position C, position D, yeah, and we need to make combinations of digits 1 in each position. So it can be like, for example, AB, set of AB, it is like 1, 1, 0, 0. Yeah, if it will be, for example, B, D, it is for which code?
0, 1, 0.
0, 1, 0, 1. Yeah, right. Is it clear? Right. Okay, then several tasks. I think you can check it at home. And the next class, if something will be difficult, you can ask me, okay?
I'm sure.
Okay. Yes, it is just tasks. So the next presentation. Minimization of partial Boolean function. There is laws of Boole algebra also. And I hope you remember the difference between total function and partial function. Do I need to revise the material or you remember? Revise? So there is a truth table for total Boolean function and partial Boolean function. Total Boolean function, it is function which has results for every input. So if we have three variables, we have 8 variants of input. 3 variables, each variable can be 0 or 1.
Who's the other one?
So each variable can be 0 or 1, 3 variables. So 2 multiplied by 2 multiplied by 2, it is 2 to the power of 3, 8 8 points, 8 variant of inputs. And in the first table too, you can see that all we know the result of the function for each input. So it is a total Boolean function. But partial Boolean function, it is function where we have inputs for example, for input 110, we don't know the result of function. For input 010, we also don't know the result of function. If we have just 1 point for just 1 point where we don't know the result of the function, so it will be a partial Boolean function. Yes, because of marker, I think. So is it clear? Yeah. And you can see x1, example 1, total Boolean function, example 2, partial. So here is the example, and algorithm of minimization, partial Boolean function. The first step, it is the difference table. We use difference table instead of boolean law because doesn't matter which result has a function in points where we don't know what this function is. Yeah. So, for example, it is point where function equals to 1. A function equals to 1 at point 1 and 2. So it is 1, it is 2. Function equals to 0 at point 3, 4, 6. So it is 4, it is 6, it is 3. Here is function 0. And this is 2 points where it doesn't matter what its function is. Yeah.
2 or 3.
And 7 also. Yes, so we don't know the result of the function. It doesn't matter what is the result of the function at point 0, 5, and 7. And the main idea of difference table that we also use boolean law, but we use these points in way, what is the better for us? Will it be 1 or 0? It depends on points where function equals to 1 and points where function equals to 0. So, for example, if so this algorithm help us to get intervals where function equals to 1, and these intervals must consist of points where function equals to 1 and points where function equals to 0 can't be here. Is it clear or it is difficult? So it is a point where function equals to 1, point just a moment, point 2, 0, 1, 0. It is 2. So each row consists of digit of point where function equals to 1. So first 3 rows, it is point 2. The next subtable for point 001, it is 1. Each column, it is point where function equals to 0. It is 3, 4, 6. 3, 4, 6. Yeah. Then digit 0, because the first position of points where function equals to 1 and points where function equals to 0, it is the same. So no difference between them. 0, 0, no difference, that is why 0. The next cell, it is first row and first position of points where function equals to 0, the second column. So here is 0. The first position, it is 1. It is difference, different digits. So here is 1 because of difference. Yeah. The next, also first position, first row, first position, 1, 0, difference, and so on. Check it, please. Yeah.
The next row, one is
Second.
yeah.
So I checked second position. Each column.
Yeah, sure. So,
1, 1,
so
0, no difference. 1, 0, difference. True. 1, 1, 0. False, no difference. The third row, third position of each column. Difference? No, no. And it is second table, subtable, the same situation. The first row, first position of each column. The second row, second position of each column. And the last row, last position of each column. Yeah.
yeah.
Then we do the same algorithm as previous class. So we need to find, so here is 2 tables, and we need to, for each table, we need to find rows which have digits 1 in each column. For example, the first table, the last row, I must to use last row because here is just 1 digit 1 in this column. And for this column, I need to use this row. So it is basis. Then it is okay. And it is also basis because of just 1 digit 1 here. Yeah. And these 2 rows together have digits 1 in each column.
Yeah.
So it is the result 0, 0, and here is dash. So for all points where function equals to 0, I use 0, 0, and doesn't matter what is here. So this interval 0 dash 0, 0 dash 0 consists of points 0, 1, 0, it is 2, point where function equals to 1. And because of this algorithm, I can be sure that no one of points 3, 4, and 6 can't be here. No one. Is it clear? Oh, great. I'm happy about it. The same situation here, the same algorithm. For the next point, point 1, for the next table, I also find intervals. The first one, because 2 rows, the first and the second, have digit 1 in each column. Yeah. And here is 2 variants. The first 2 rows and the second, and the 2 last rows. 0 dash 0, 1, it is the second variant. Is it clear? Yeah.
I have a question because we have 0, dash and we have dash 0, 1.
Yeah.
These are like 2 variants.
Two.
But why did you write them together and answer?
Together answer, you mean here?
I mean, the function,
One next to
the function x1, x2, x3 is equals to
0 dash.
0 dash 0, 0, 0 dash,
Yeah. We use here all of variants.
all the variants at
All.
once. We don't write like f1 and
No, it's not it is point 2, it is point 1, it is one function. It is one function. For each point, for point 2, for point 1, we find intervals. And you're absolutely true. We can use just one variant, but there is next step which can help us to remove redundancy. Yeah, yeah. So because of it is very small, very easy example, but when we have big example, here can be a lot of points where function equals to 1, and we can get a lot of intervals which consist of several points where function equals to 1. So it can be more complicated. Yeah, but you're right. Here is actually there can be 2 variants. And so, do you have questions? No?
I don't have any question about the difference table. So we just use difference table if we don't have in the partial function, no?
The first table
Yeah.
is just for partial Boolean function. Yeah, for total Boolean function, we use just Boolean law. And the next step, implication table. So here we find intervals which together consist of all points where function equals to 1. So it is points where function equals to 1, point 2 and point 1. And here is our intervals which we got in previous step. And digit 1 if point in this interval. Yeah. Do you remember from previous class? Implication table, absolutely the same step. So here is intervals from the previous step. Here is points where function equals to 1, it is 2 and 1. 2 points. Here is 1, here is 0 because of these points are here. These points not are here, are not here.
Understood.
Hmm?
Understood.
Mhm. The same situation here. It is false because of 0, 0. Here is 0, here is 1. It is true because of 0, 0, 1, 0, 0, 1. And then we also try to find rows which have digits 1 in each column. So it is necessary to use this row because of just one digit 1 here in this column. And 2 variants because for this column, this row, and for this column, 2 variants, this or this, 2 variants, and 2 functions. So you was absolutely correct and clever. Thank you. So do you have questions? No? We learned about partial Boolean function just for exam. In your coursework will be total Boolean function. Coursework.
In the exam, we need to do this different state of boolean.
In exam, yeah, there will be one question theoretical and one example, and example will be like this. So we can practice. Maybe someone wants to have a practice. Or I can do it for you. Hmm? Okay, so let's use this example. F of x1, x2, x3, x4, 0 at points 1, 4, 6, 1, 4, 6, 7, 10, 4, 6, 7, 10. Function equals to 1 at points 2, 11, 12, 14. Okay, and the first step, it is difference table. So it will be 1, it is 0, 0, 0, 1. 4, it is 0, 1, 0, 0. 6, 0, 1, 1, 0. 7, 2 plus 1. And 10,
1, 0, 1, 0.
1, 0, 1, 0. 8 plus 2, I think. And points where function equals to 1, it is 2, 0, 0, 1, 0, 11, 1, 0, 1, 1, 12, 8 plus 4,
One is almost
and
1 is
14, 8 plus 4 plus 4. Okay, so we'll have 1, 2, 3, 4 tables. For the first table, point 2, 0, 0, 1, 0. And 1, 2, 3, 4, 5 column. Okay, so it is 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, and 0, 1, 0. And let's check difference. So it's the same, it is 0 or empty. Let's use empty because it is more comfortable for us. So it is 0. 0, 0 empty, 0, 0 false, 0, 0 false, 0, 1 difference, true, difference. The second position, second line, second row, second position. No difference, 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 no. The third position, third line, third row, third position, difference, difference, no, no, no. And the last one.
yes.
Okay. Is here basis,
The first one.
the first row, yeah? The first row, it is basis, and it is just the last column. Okay. And one more row. Also, it is basis. 2 rows, it is basis. Okay. So how many variables here? For intervals, how many intervals will be here?
Here we have
First, second, and one
One
of
is two less.
the last two.
Mhm.
So, first, second, third, it is one variant. And-
First one.
Fourth, it is second variant.
Mhm.
Two variants. For the first one, it will be 001 dash. 001 dash. And for the second, 0 0 dash 0. Right. The next table, point 11. 1 0 1 1. The first one.
Different.
0. The second.
No, different. Difference. The last one. You have this is the last one.
The last one basis, yes. And the last basis. And how many variants here?
Yes,
Dash.
two there.
Two variants. The last one and
The first one.
the first one.
Now we have the second one, third one, and the last.
And last three. Mhm. Yeah. And we use all of them because here is maybe the first one is better because it's shorter,
Yeah.
but maybe not because this variant can it may be a situation, it may be example where this point, this interval just for one point, but this interval for 2 points. So it can be better than this one. But I'm not sure in this case how will be. Okay. So 2 intervals, yeah? 1 dash dash 1. 1 dash dash 1. And the second? Dash 0 1 1. Dash 0 1 1. The next. 12. The first one, the same, okay? 1 1 1. Opposite. 1 2. 0. Opposite. 1 1 1. And 0 opposite.
First one is this.
The second one is the doubles.
The first one basis. Second one. No, second one, no basis.
We have two booleans.
Just one. And yeah, so this row for each column, but not for the last one, and for last one, two variables. So it is the first, it is the second. It is one dash dash. And one dash zero dash. Is it? No. Difficult. Okay, and the 14. 1 0. One. The second. 1 1. The next 1. And the last one 1. So it is basis. It is basis. And when we have basis from rows which have digits 1 in each column, it is just one variant.
I'm not getting the point only, but we will 0 1 dash
1 dash
double.
is
So you're talking.
it is the first table.
Just.
So is it clear one I circled
Yeah.
this digit because just one in column. So without this row, it's not possible to cover this column. Yeah. So it is necessary to use this row because of just one digit one here, and this because of just one digit one here. So it is necessary. It is basis. Then this basis, two rows covered column this, then this, and this, but not this. So I need to add here, to add in this set of two rows, I need to add someone else, some rows who have digit 1 in this column. And it is this row or this row. That is why two variables. So I can use 1, 2, 3, or 1, 2, 3. And 0, 0, dash 0, it is the second variant. So dash means that I don't use the row. So 0, 0, dash 0. I don't use this row because these three rows, 1, 2, 3, covered all columns with digit 1. And it is the second variant, yeah, also clear. Maybe more questions? Okay. So the last one, it is just one variant. It is clear, but why? Yeah. Is it clear why here is just one variant? For this column, it is necessary to use second row. For this column, it is necessary to use first row, and they are together covered all of column. So no variance, just one variant. One dash dash. One dash dash. Yeah. Okay. Because of idempotentive law, A disjunction A, it is A. I can remove this because of the same. And that's all. 1, 2, 3, 4, 5, 6, 6 intervals. Is it clear how I can get function from these intervals? Or I need to show? So if so it is position for x1, it is position for x2, position for x3, and position for x4. If dash, that means no. If dash, it means that no variance here. If zero, it means x3 with negation. If 1, it means that x1 without negation. So it will be x1, not x3, conjunction, yeah, between the junction and intervals together with disjunction. So this is the function after difference table. Do I need to get this function or it is clear? Clear, yeah? Great. And length will be 1, 2, 3, 4, 5, 6, 7, 8, 15. Length will be 15. Okay, that's the next step. Implication table. So we need to remove some intervals from our function. And we use for this aim implication table. Rows, it is our intervals from the previous step. So intervals 0, 0, 1 dash, 0, 0 dash 0, 1 dash dash 1, dash 0, 1, 1, 1, 1 dash dash, and 1 dash 0 dash. So it is rows and columns, it is points where function equals to
1.
1. It is 2, 11, 12, and 14. Here is, I put in cell digit 1 if point from column includes in interval from row. So this interval consists of points 0, 0, 1, 0, and 0, 0, 1, 1. And you can see that point 0, 0, 1, 0, it is point where function equals to 1. Yeah. And this point 0, 0, 1, 1, what is it? It is point where doesn't matter what function is. Yeah. So in a difference table, we put this point into interval where function equals to 1, because of doesn't matter what function is in this point. And okay, digit 1 here, not, no, yeah. 1, 0, 0, 0. Is it clear?
Yes.
Okay. The next one. Also 1, 0, 0, 0. The next. 0,
0, 1,
1, 0,
1, 0, 0.
0, 0, 0, 0, 0.
Are you sure?
Yeah.
Instead of dash, I can put 1 and it will be this point.
1,
Yes.
1,
0,
0, 0. The next.
0, 0, 1,
1, 1. Yeah.
0,
0,
0,
0, because of difference here.
1,
1, and 0.
0.
0, yeah, 0. And also the task is to find cover for each of column. So basis, it is this row. Yeah.
Yes.
So it is necessary to use this interval. And this interval covered this and this column. And I need to cover two more columns. For example, this row for the first and this row for the second. Or this and this. Or this and this. Yeah. And just 1, 2. This and this also. So two variants here, two variants here, 2 multiplied by 2, 4 variants. Yeah. 4 variants. And you can see them here. 4 variants, P1, P2, P3, P4. And functions.
Which would be
Hmm? Do you have questions? Is it clear how we get variants and then functions? So P1, it is function F1. Yeah, if 0, 0, 1 dash, then not x1, not x2, x3. And length, it is and we can use distributive log later, and length will be 6. Because of distributive log, here is 7, length is 7. And here is length less because of distributive log. X1 here and X1 here. Okay. Do you have questions? Is everything clear or is everything difficult?
Just too complicated to just minimize a Boolean function. We need to go through all of that.
You mean this example complicated?
Yeah, this is not minimization. I mean,
It is minimization.
that, yeah, I understand, but it's not minimization.
Ah,
There's steps to
not
minimize.
too many steps, but you can write program for computer and
Understand. That's what I asked if we have an example, because if you just miss one digit, everything's wrong in the table as example. And I need to be careful to do.
Yeah, you have to be careful. But you can check if you know the result, so you can check the result. You have points and you can check if the point where function equals to 0 or not. If it is mistake. You're more clever than computers, so
It's
okay. So we have just 10 minutes,
5
5 minutes.
timetable.
So if you listen clearly, I can say thank you for your attention.
Oh, that's good. There will be any appendix by your class or